Tomorrow morning, Emma is told that every engineer on her team will gain the output capacity of an entire development department. Not literally 1,000 people, but enough AI assistants to multiply code, tests, documentation, and prototypes. That sounds like a productivity breakthrough. It is also a salary question. If software production becomes abundant, which skills still earn promotions, protect salary leverage, and remain scarce? The answer is not simply typing faster. It is learning how to lead all that output toward the right result. Emma manages a growing software team. Her headcount has barely changed, yet generated work now arrives at a completely different scale. Pull requests pile up. New services appear sooner. Documentation expands. At first, the dashboard looks impressive. Then the coordination bill arrives. Reviews slow down, teams choose different patterns for the same problem, and senior engineers spend more time reconciling decisions than writing code. For years, many engineers built career value through implementation. They learned a language deeply, wrote cleaner code, solved difficult tickets, and became the person who could finish hard work quickly. Those skills still matter, but AI lowers the cost of many implementation steps. When acceptable code becomes easier to produce, raw output becomes less scarce. The bottleneck moves upward, from writing software to deciding what should be built, how it should fit together, and how anyone can tell whether it is safe. That changes the career economics. If your value is measured mainly by how much code you personally produce, AI may compress an advantage you worked hard to build. If your value comes from understanding customers, system boundaries, operational risk, and long-term trade-offs, AI can increase your leverage instead. One architectural decision can now guide hundreds of generated implementation choices. One vague decision can multiply inconsistency just as quickly. The same technology can weaken one kind of career capital while strengthening another. This is why the metaphor of 1,000 developers matters. Imagine managing a huge engineering organization with no shared standards, no documented architecture, and no clear ownership. Even talented people would create conflict. AI does not remove that problem. It can accelerate it. One assistant selects a new dependency. Another invents a different authentication flow. A third rewrites a stable component because it looks inefficient in isolation. Each output may look polished. Together, they can create a product that becomes harder to operate, secure, and maintain. The organizations that benefit most will not only buy better models, they will build better systems around those models. Reusable context becomes infrastructure. Architectural decisions become written guidance instead of memory held by a few senior people. Coding standards become operating instructions that humans and AI can apply consistently. Automated tests, security checks, and fitness functions become quality gates that stop bad patterns before they spread. Model capability still matters, but the surrounding system determines whether speed becomes durable value or expensive rework. Engineering leadership changes as well. Managers once spent much of their time allocating scarce developer hours. Which project gets the team? Which feature waits? As implementation becomes easier, the harder question becomes alignment. Which outcomes matter? Which constraints cannot be violated? Which decisions should remain centralized, and which can be safely delegated? Leadership shifts from distributing labor to designing the environment in which human and AI contributors make compatible decisions. Software architects and staff engineers become important for the same reason. Their value is not that they can predict every line of code. Their value is that they can make trade-offs visible. They can explain why one design is safer, where a shortcut creates future cost, and which system boundary protects the business from cascading failure. When AI can generate more implementation, clear judgment reaches further. The role is not disappearing. Its leverage is expanding. There are limits. A small team building an early prototype does not need the same governance as a bank, hospital, or global platform. Better models will understand larger code bases and follow instructions more reliably. Strong prompting and strong implementation skills will remain useful. The point is not that every engineer must become a formal architect. The point is that career value increasingly comes from owning decisions that cannot be reduced to code generation alone. So what should an engineer do with this? Use a 4-question career test. First, can you explain the customer consequence of a technical decision? Can you also explain its operational consequence? Second, can you turn repeated judgment into reusable context, standards, or quality gates? Third, can you define what good output means before AI begins producing it? Fourth, Do you own a decision, boundary, or risk that the organization would struggle to replace? These questions do not guarantee a promotion or protect every job. They reveal where your skills sit relative to the new bottleneck. Emma eventually stops treating the flood of generated code as the main success metric. She measures whether teams are reusing the same patterns. She checks whether quality gates catch problems early. She asks whether architectural decisions are clear enough to survive beyond one conversation. Her strongest engineers do not compete with AI by typing faster. They use AI to extend judgment that the organization already trusts. Their output matters because it remains connected to customer outcomes, system reliability, and financial consequences. AI may give every engineer something that resembles 1,000 virtual developers. The exact number is only a thought experiment. The real shift is that production capacity is becoming easier to access while coherent direction remains scarce. For your career, the practical question is not only how much can I generate? It is, what decisions can I lead? What standards can I encode? And what risks can I prevent? In a world of abundant software, the engineer who can organize intelligence may become more valuable than the engineer who only produces more of it.